friendly diagram.
In a reflex arc, sensory information is processed at the level of the spinal cord, resulting in action without involvement of the brain. For example, if one's fingers are burned by a candle, the hand that receives the painful stimulus is rapidly removed from the flame with a jerking motion. At the same time, the brain is receiving information indicating that a painful event occurred in the hand. It is important to understand that although the brain may perceive the painful stimulus, the reflex arc acts to retract the hand without direct input from the brain.
So this is actually really important. When I was a kid, I used to walk around barefoot all the time. And one day, my dad, who had a bunch of nails and these boards poking up, didn't have them in a very safe place for young Mr. McDaniel to be wandering around. I was actually not running, but I was walking, and all of a sudden, my foot went right over the tip of the nail. Now, what did I do? Well, that prick hit my foot, and then what did I do? I stepped back. Did my brain have time to process that? No. My interneurons thought for me. And it quickly sent a signal saying, get away from that nail. If I didn't have that reflex arc, I wouldn't have just a prick. But my goodness, I would have had a nail all the way through my foot. Thank goodness for the reflex arc, right guys? And who here thinks they've got really good reflexes? Tatiana? Awesome. Anybody else? Drake? Shemaya, you think you're good with this? How about I have Tatiana and Shemaya come on up really quick. We're going to see just how good your reflexes really are. Come on up. All right, so it takes time for these signals to move up and down your visual senses, your brain to process it, and for you to make a physical reaction. Here's what I'm going to have you two girls do. I'm going to go ahead and drop one of these, or both of these, at the same time. All right? Now we're going to measure how long it takes for you to visualize when I drop this and to respond. You ready? This is what you're supposed to do. How are you going to do this? When you take your hands together like this, two hands, this, have just a little bit of gap in between. Excellent. And so when I drop this, you're going to go and close it. We're going to see how far it'll travel before you are able to catch it. Now let's come a little closer so that I can go ahead and drop at the same time for both of you. So let's have you girls. All right, there now. Both the same distance. I want you girls to close your eyes and open them. And then I'm going to drop this any minute. And you're going to have to. Ooh, pretty good. Pretty good. Let's see. Oh, you guys are about right in charge. It dropped about 48 inches for both of you. Pretty good. Anybody think you can do better?
No.
No? Drake, come on up. Let's see if you can go ahead and beat 48 inches. Or centimeters. All right, we'll do it right here. So this side of the class can see. All right, Drake. So, what you're going to do, you put your hands together. Just like that. Now what I'm going to do, when you open your eyes, I want you to realize that once I drop this, you need to close your hands. Are you ready? All right. 1, 2, and 3 in. Oh, good. All right. 1, 2. Oh. Okay, you ready? One last time. Come over here a little bit more. All right. And I'm going to drop 80. There you go. Look at that. 48 centimeters. You guys are all about the same. But wouldn't it be better if you could make this a little quicker? I mean, are you going to be able to catch a fly during that time?
No.
No. No. You have to use other things, like your cognitive ability, your brain, to think about this in order to actually anticipate where the fly will be. This brings me up to the next thing we're going to talk about today. Skipping ahead, the brain. Oh, I love the brain. I've got how many neurons inside my brain? 100 billion. Oh, thank you, brain. And today, we're going to talk about 4 different parts of the brain. Right up here. All right. So, The first part of the brain is called the cerebrum. That's this big part right here. And it does lots of good things for me. And what I'm going to do, guys, is that I'm going to go and pass out a part of my cerebrum to you guys. So you can go and see exactly what the cerebrum looks like inside my model.
I remember this.
Starting over here. So my cerebrum does 4 major things. What's one thing it does, Roberto? Excellent. Diana, what's another thing the brain does? Great. Christina Vane, what's another thing that my cerebrum does? Beautiful. And Christy, in the back, what's the last thing the brain does, or the cerebrum?
Learning and memory.
Learning and memory. And the cerebrum is this big part right here, and it's actually got 4 different parts I'm going to talk about in just a moment. So your cerebrum is where we do most of our higher level thought processes. Your personality, who you are, what you think, what you feel, is all done inside of the brain, and particularly in that cerebrum. All right, 10 seconds. We'll move on to the 4 parts of the brain. Cerebrum. Oh, I'm sorry. They left. We don't need her anymore. We'll come back to her later. It's an undefined gender. All right. All right, so here's the 4 parts of the brain, of the cerebrum. Because the cerebrum is, in my opinion, one of the best parts of the brain. There's the frontal lobe. This is where you get a lot of your cognitive thoughts. Your analytical reasoning is all found in the frontal lobe. The next part is the what, Dee? Temporal lobe, yeah. This is where a lot of our sense of sound is processed. When we hear something, it's often the temporal lobe that processes that information. The third lobe is a tough one. Tatiana? Oh, really close. This is the parietal lobe. Parietal lobe. This is where a lot of our emotions are processed. And it's not too far away from where our memories are stored, kind of in the middle of the parietal lobe, just underneath it. And the last one, let's see here, let's ask Mala, what is the last lobe of the brain? Occipital lobe, yeah. That is an important part of our brain for sure. Anybody know what the occipital lobe does?
To see.
Oh my gosh, yes, to see. It's exactly what it does. Beautiful. All right, here's the next part of our brain. This is located right here, this little brown thing that's on this lower end. The cerebrum is responsible for 2 major things. One thing the cerebrum is responsible for is...
Cerebellum.
Oh, this is cerebellum, thank you. It's responsible for regulating my sense of balance. So, you know, my ability to walk on one leg, to hop, to skip, to twirl around, all of that is done by my cerebellum. It's also responsible for coordinated voluntary muscle movements, like these guys up here. So, Alex, what's the name of the part of my brain that regulates my sense of balance?
Cerebellum.
Cerebellum, good. Ryan, what is the name of the part of my brain right here that's responsible for coordinated voluntary movements? Cerebellum. 10 seconds. And I'm going to pass out my cerebellum to you guys. So you guys, you can look at this. Let's see what my cerebellum looks like. And yours. Okay. The next part of the brain, one of my favorite words in science to say, is the medulla oblongata. the medulla oblongata. Class, say that with me. Medulla oblongata. And this is what's responsible for breathing, for heart rate, blood pressure, and swallowing and digestion. What do you guys know about all those things? Are those important for staying alive? You bet. Did you guys know that if you had a serious brain injury, for example, if all this part of your brain was just turned to mush, you could still be alive? Well, what does that mean to be alive? You might be brain dead, right? But your body could still be functioning. And your body can still breathe. Your body can still have a heart rate, blood pressure, and swallow and digest. Then your body could still be alive. You know, it'd be more than paralyzed. Anybody ever heard of the concept of being brain dead?
Vegetable.
This is when people who've had such dramatic injuries to most of their brain that in essence, this whole part of their brain is dead. Your thoughts, your feelings, your emotion, who you are, your memories have been wiped away. But you're still breathing. In some ways, yes. Here's a coma patient right here. It might be somebody who physically might still be alive, but mentally, not anymore. All right, this right here, this base is where I have my, say it with me, class, medulla oblongata. The last part of the brain is the pons, right there. The pons is really interesting. It connects my big cerebellum right here to my medulla oblongata. This is also responsible for helping control rates of breathing. And, believe it or not, the pons, scientists believe, this is where your dreams are formed. It takes all of these thoughts, these images that are happening in your occipital lobe, your temporal lobe, your frontal, even your frontal lobe, and it helps to form the dreams that you have. Right there in the pons. All right, guys, 10 seconds. That's it. Oh, we're almost there.
We have one more.
Here you go, guys. This is your exit ticket, but here's the good news. This exit ticket, you'll see tomorrow. Here's a clue on your daily calendar tomorrow.